How does PLC analog input versus analog output modules work in a real industrial system? Start with one mental picture. Energy or information enters. The equipment changes it in a controlled way, and a measurable result leaves. We will follow that path and identify what can prevent it from working. The essential working parts are field transmitters, the analog input module, PLC engineering values, the analog output module, and the final control device. Each part has one responsibility. Keeping those responsibilities separate makes the system easier to understand, test, and troubleshoot without confusing a displayed command with the physical condition in the field. An analog input receives a field signal, such as 4 to 20 milliamps, and converts it into a digital value for the PLC. An analog output performs the opposite direction, converting a commanded value into current or voltage for a positioner, drive, or indicator. Watch the direction carefully. The next action depends on the previous action completing correctly. Exact settings, fail actions, and timing remain specific to the approved plant design. Scaling is the translation layer. Raw counts become engineering units on the input side, while an engineering command becomes output counts, and then current on the output side. Incorrect ranges can make healthy wiring appear wrong. This hidden relationship is the key to understanding why a normal-looking display can coexist with a field problem. Quick check. A pressure transmitter sends 12 milliamps to the PLC. Which module receives that signal? The best answer is the analog input module. The question separates the system's main mechanism from nearby equipment that may only display, supervise, or support the action. Open circuits, wrong channel type, missing loop power, reverse polarity, and mismatched scaling cause common faults. Force and simulation functions must be controlled because they can bypass the real field signal or command. A safe diagnosis compares command, feedback, process response, and local condition instead of trusting one screen or one measurement. Verification should follow the complete path from the initiating signal to the physical result and back through feedback. Record the as-found condition, use approved test points, restore every bypass and isolation, and confirm normal operation before returning the system to service. Analog input brings measurements into the PLC. Analog output sends continuously variable commands back to the field. Remember the direction of energy or information, the hidden conversion, and the feedback that proves the result. Before field work, follow the plant SOP, PTW, isolation, depressurization, venting, draining, PPE, LODO, approved test procedure, and supervisor instructions.